This video allows for a self-paced review game, the typical multiple choice that we go through before a test. This is for electric circuits. Topics covered on the test are Ohm's law, resistance, power, series, as well as parallel circuits. First question, as more resistors are added to a series circuit, what would happen to the total current flow? Okay. See, the correct answer here is decreases, because as more resistors are added to a series circuit, the total resistance increases, thus lowering the total current flow. Second question, all right, household wiring consists of which type of connection? Series, parallel, or combinations of them? The correct answer is parallel. And the reason why it's parallel is that you want all of your devices in your home to receive the full 120 volts of the circuit. You want each thing to be on their own loop, and you do not want them to have to all run at once, which in series you have to have everything connected to ensure a current to flow. Alright, third question. This is a circuit problem. Parallel circuit, a 10 and 30 ohm resistor connected to a 10 volt source. What would the voltage drop across the 30 ohm resistor be? This one would be 10 volts, because in a parallel circuit you get a full voltage drop across each branch of the parallel circuit. Notice here in the key, this battery is oriented with the positive terminal downward, so the high voltage in this case is denoted by the red. The low voltage at 0 volts is blue, so you get a full 10 volt drop across each resistor. Okay, next question. Which of the variables provided below, if you were to increase them, would decrease the resistance of a wire? Its length. Cross-sectional area is a fancy way to describe the thickness of the wire, as well as the temperature. Correct answer here would be the cross-sectional area, because the thicker a wire is, the easier it is to push electrons through it. Alright, so a thicker wire would be easier, hence have a lower resistance. If you had a longer wire, it would be more difficult to push the electrons through. Also, if you had a warmer metal wire, it's also more difficult because the atoms have more chaotic motion at higher temperatures, and it's harder to push electrons through them. Another circuit problem. What would the total resistance of two 50 ohm resistors connected in parallel, what would that equal? You don't have a voltage source in here, so you can't actually determine any current flow, so you can't work backwards. So in this instance, you are actually forced to use the reciprocal formula for the total resistance in parallel. So here we have two 50 ohm resistors, both R1 and R2. So when you add 1/50th to 1/50th, you get 2/50ths. Have to flip that over for the reciprocal, and you get 25 ohms. Which of the following units measure electrical energy? Volts, joules, kilowatt hours, or two of those three? And the correct answer here is both joules and kilowatt hours. Volts measure voltage, which is not energy. Remember, we talked about 3.6 million joules being equivalent to a kilowatt hour. Kilowatt hour is what shows up on your electric bill, which is why it was introduced in this section. If you were to add more resistors to a parallel circuit, what would happen to the total current flow? Here the answer is increases. Sometimes this is counterintuitive. As you add an additional resistor in parallel, the total resistance of the circuit actually decreases, thus allowing for more current to flow. When you add a new branch, you still get the same amount of current flow on the existing branches. So by adding a new loop, more total current will flow regardless of the resistor that's on the added loop. What does an ammeter measure, and how is it connected to the resistor within the circuit? Well, an ammeter measures amps, so it measures current flow. It's also placed in series with the resistor. In another way, we talked about how it's connected in the circuit. So if I had a resistor here at some point in the circuit, my ammeter could be placed either right before the resistor. It could also be placed immediately thereafter to measure the current that flows through it. How many 60-watt light bulbs could be connected to a household 120 volt circuit to trip a 20 amp breaker? Right. There are multiple ways to do this. The correct answer is 40 bulbs. If you were to apply the power formula for a single 60-watt light bulb on this circuit, it would draw a half an amp. So it would require 40 bulbs to pull a total of 20 amps, thus tripping the breaker. This same circuit, what would the overall resistance of the previous circuit be if you had all 40 of these light bulbs plugged in? Right, well, easiest way to do it, if we had all those bulbs plugged in, we would get a total current flow of 20 amps flowing with a total voltage of 120 volts. Therefore, the total resistance here would be 6 ohms when taking 120 volts divided by 20 amps. Now a series circuit problem, 10 volt source attached to a 10 and 30 ohm resistor. What would the voltage drop across the 30 ohm resistor equal? Okay. Correct answer here is 7.5 volts. Easiest way to do that is to take the total resistance of 40 ohms, which allows you to find the total current flow coming out of the voltage source to be 1/4 of an amp. When that 1/4 of an amp goes through the 30 ohm resistance, it will drop the voltage by 7.5. If you were to do it on the 10 ohm resistor, you would get 2.5 volts, which would be the total 10 volt drop. But the drop just across the 30 ohm would be 7.5. What happens to the overall resistance of a series circuit when more components are added? Right, the total resistance would just increase, because as you add more resistors in series, you just add on, thus leading to a higher ohm value. Here's a cost problem. 5,000 watt dryer running for 20 hours. How much would it cost to consume the electricity? Let's make the assumption that the rate is 10 cents per kilowatt hour. Correct answer here is $10, because the dryer would operate at 5 kilowatts for 20 hours. Multiply those, we get 100 kilowatt hours of energy multiplied by 10 cents, which leads to $10. Find the resistance of a hairdryer rated at 1200 watts when attached to a 120 volt circuit. This is a two-step problem. You have to determine the current flow through the hairdryer, which is 10 amps, which then allows you to use Ohm's law to find the resistance, which would be 12 ohms. Hence E, more than 10 ohms is the correct answer. What does your electric bill charge you for? And the correct answer is energy. Common misconception to say power, right? Energy measured in kilowatt hours. Total resistance for a 6 ohm and 12 ohm resistor attached in parallel. Without a voltage source value, you'd have to use the reciprocal formula. Do a little bit of a lowest common denominator math here. 1/6 plus 1/12 leads to 3/12, which you would then flip to get 4 ohms. Overall current flow of a parallel circuit when more loops are added would increase. All right, as mentioned earlier in the game, a new loop leads to an extra flow of current, leading to an overall greater value. If you remember the lab we did, when plotting voltage versus current, the slope of that graph would equal what quantity? Correct answer is resistance. Remember, slope is rise over run. You would get voltage divided by current flow, which, using Ohm's law, leads to resistance. A voltmeter measures what, and how is it connected to a resistor? Not too crazy here, right? It measures voltage drop, and it's connected in parallel, which means it's outside of the circuit. So if you were to draw it on an existing schematic, your voltmeter here in pink would be placed outside of the circuit, touching each side of the resistor. Last question, ohm is the correct unit for which quantity? And as we've had throughout the game, it is the correct unit for resistance. Good luck on your test. Make sure to study your notes, your virtual textbook as a source, all homework sets, problem sets that we have had.